I think we're recording. So this is circles. This is section. Oh, look at this pretty pink. Should I write pink? 1-7. Circles. Circles. This is a picture of a circle. Where's a picture of a circle? There. Picture of a circle. Anyone give me a definition of a circle? Who can tell me what a circle is? How do you make a circle? Are you still asleep? Yes? Okay. A circle is a round thing. No. A circle is an infinite set of points a given distance from a fixed point. Can you see that, Ian?
Yeah.
Okay. So a circle is an infinite set of points a given distance from a fixed point. That fixed point right here, we'll call this P, is called the center. Okay, so this thing is the center of the circle. And who can tell me what that given distance is called? The distance from here to here. What's that distance called? That's the radius, okay? So the given distance is called the radius, all right? And so when we talk about circles, at least in this book and in most books, well, the points inside the circle are not really part of the circle. So just the outside, it's like a line, it's these points. If I plotted all the points that are some distance from this center point, okay, I would generate this circle. So it's just the points that are just the points on the outside. Okay? So let's do I still have that book up? Let's define some parts of circles. So let's see if I could pause for a second. Oh, let's not pause. Let's go to my book. Here's the book. Okay? And I would have, no, not that. Keep going. Keep going. Keep going. This is a cartoon. You want to see the cartoon? And it said, we always skip the cartoons. It says, behold the new wheel. It's an improvement on the square wheel. Improvement? Yes, it gets rid of one bump. All right. Anyway, so these are chords. Let's look at this. So, whoops, I didn't place a capture in a new page. I want to place it in a new page. It's okay. So who can look? We're not going to have a sheet and all that kind of stuff. But looking at these things that are chords and not chords, who can tell me what a chord is? What's a chord of a circle? Go ahead, Evelyn.
The chord of the circle is like a diagonal.
It's not really a kind of like a diagonal, but there's no vertices to connect to. So these are chords. This is a chord. These are not chords. Try to be a little more specific. Who's got another definition of chord? Come on, don't just sit here like a bump. Go ahead, Trevor.
Are they lines starting and ending, or line segments starting and ending inside a circle?
Starting and ending with its endpoints on the circle. Okay? So that's what a chord is, okay? A chord is a segment with its endpoints on a circle. So notice that this is not a chord. This is not a chord because its endpoint is not a circle. This is not a chord because it goes on forever and it doesn't have two endpoints on the circle. And when you write a chord, you just write it as if you're writing a line segment. A, B, C, D, E, F, G, H. What's this thing called here that goes through the center of a circle? A diameter. Is a diameter a chord? Yeah, so it appears that with this definition, a diameter is a chord. Could I move on? Yes? Go ahead. So moving on, a diameter, that's the next thing we talk about. Whoops. Yeah, Marshall. So here's a diameter. Who can give me a definition of a diameter using the word chord? Using the word chord. Go ahead, man.
A chord that passes through the center.
Perfect, okay. A diameter is a chord that goes through the center of the circle. A chord that passes through, I like your words better. Pass through the center of a circle. Just three real definitions here. Easy enough? Moving on? Easy enough? Elise? Yes? You're good? Okay. And the last thing we're going to talk about is this one here. Partial. A tangent. This one's a little more obscure, but who can try to give me a definition of a tangent? Look at a tangent. Tangents, not tangents. How many times does it hit the circle? Once, okay? So is it a chord?
No.
Is it a line?
Yes.
So a tangent is a line that touches a circle at one point. Okay, at exactly one point. Okay, so that's all you really have to do. Okay, a tangent is a line that touches, intersects if you want, touches a circle at exactly one point. Tangents are pretty important in real life. You know why? Anyone know why? Tangent. It's a tough crowd here today. All right, so moving on. When we draw circles, so if I were to draw a circle, and sometimes we'll use abbreviations, so say this is circle S or something like that, I will sometimes abbreviate going like this, circle with circle S. Okay, I'll put a little circle with a dot in it, and that means circle S. Okay, just like segments and stuff like that. Tangent, diameter, arcs. Okay, an arc of a circle. An arc, and this isn't really on that sheet. An arc is a piece of the circle. Okay, so an arc is a part of the circle part of a circle between, am I recording? I'm recording, okay? Between 2 points. Endpoints. Endpoint. So like this is AB. So this is arc AB. AB. And you draw a little curvy bar above it like that when you're indicating an arc. Okay? And this is called a minor arc. A minor arc is less than half of the circle. Okay? So it's less than a semicircle. Less than. I probably need to talk about a semicircle. Less than half the circle. Minor arc is less than half the circle. Let me draw another picture. Here's another picture with this. I'm going to go like this and go through the circle. This arc from here to here, we'll call this CD, and go this way. What's that called? Half of the circle. Semicircle. Okay. Semicircle is half of the circle. The circle, or another way you could write it, is an arc with endpoints on the what? Endpoints on the diameter. Okay. Now with a semicircle, could be some confusion. Like, say I want to talk about this. Say I want to talk about this semicircle over here, like this one going from here to here. I have to name it by 3 points because I don't know whether you're talking about this one or this one. Okay? So in this picture, I'm going to call this at point X and this point Y. So if I want to talk about the green one, right, that would be semicircle, CYD, you name it by 3 points, and you put a little curvy on the top. If I want to talk about this one, what would I call it? CXD or DXC. You always put the point in between in the middle, okay? Or DXC is another one. DXC would be the other semicircle. Questions about that? So we talked about a minor arc. A major arc, guess what a major arc is? No, a major arc is like Noah's Ark, because that is pretty major, you know. No, just kidding. A major arc is like Joan of Arc. It is pretty big too. Or the Arc de Triomphe in Paris. You know, that's okay. No, a major arc is more than a semicircle. More than a semicircle and a semicircle. So it's an arc that is greater than 180, but less than how much? All the way around the 360 degrees. Okay, so because all the way around, you guys know that's 360, right? You jump off on your snowboard when you're doing your snowboarding tricks. You do 360, so that's a full circle. So a major arc is more than a semicircle and less than 360. So say I have this picture right here. Who can give me a major arc on this one right here? You have to name a major arc, just like a semicircle with 3 points. So a start point, an end point, and a point in the middle. Who can name a major arc for me? Sorry. Go ahead, Drake.
X. Wait.
But we don't want to start at X.
No. Yeah, no.
You could, I guess. No, I guess you could. Go ahead.
X. Wait, so you have to have
What?
3 points?
Yeah, 3 points. Go this way.
Okay, X, C, D.
Yep. Okay. X, C, D would be one major arc, right? Because it goes from X. You could call the same arc X, Y, D, right? So as long as it has a point in the middle, it X, C, D, or X, Y, D, or D, Y, X, or D, or D, C, X, whatever you want to call it. Okay? So that's a major arc. Couple more things, and minor arc, major arc, minor arc, semicircle we talked about. Just one more thing, and oh no, a couple more things. Okay? If you see this, like if I said that circle P is congruent to circle Q, that means that they have congruent what? Diameters or radii, yep, okay. Congruent diameters or radii, that's the plural of radii, okay? So circle O and circle Q, if I want to draw two congruent circles, here's O, or P, sorry, here's Q. Let's see if I can make them look about the same size. So here's P, whoops, I didn't mean to do that. Change colors. Here's circle P, here's circle Q, and then you might have a picture, something that looks like this with, whoops, I want this thing. So if I go like this, and like this, okay, this indicates that those two circles, if that is true, then this statement is true, okay? Congruent circles. That's called congruent circles. Anyone know what concentric circles are?
Is it circles inside?
Yeah, kind of like the target, you know, when you go to Target, and the target symbol, it's like this, or any target for that matter. Those are concentric circles, okay? Isn't that cool, the way I could use my tool to do that? Okay, that's, those are centers with the same, circles with the same what? Same center, okay? Those are concentric circles. One more take I'm going to tell you. How you measure an angle, okay? Oh, man, those don't look very circular from back here, do they? No, that's because the screen distorts. On my screen, they look circular, but on your, that screen distorts, so they look kind of. Can I move on to the next thing? Next thing? Okay. Next thing we're going to talk about, well, is the angle or arc measure. Arc measure. So if you have a circle, where's a circle? Here's a circle, and you draw an angle in here like this. Boom, boom, and say this is, say this angle here is 57 degrees, and I'm going to call this point D, E, F, okay? The arc, okay? Angle DEF is called a central angle. Okay? the measure of arc DF is equal to the measure of its central angle. So the measure of DF is, what's the measure of DF? How many degrees is it? 57 degrees, okay? So the measure of DEF is equal to the measure of the arc, DF, which is equal to 57 degrees. So does the measure of this arc depend on the size of the radius? No. Look, I could have another circle that's way smaller than this, okay? And I could draw in another angle that's 57 degrees, okay? So say this is 57 degrees. What's the measure of this arc right here? Yeah, so arc XY, the measure of XY is also equal to 57 degrees. So it doesn't matter what the size of the circle is, it's based on the amount of the opening, okay? Say we're to put a P here. Who can tell me what's the measure of DPF? What's the measure of DPF? Right, Ryan.
303 degrees.
Perfect. How did you get that? How did you get? Go ahead.
Well, because since the angle that isn't included in DPF is 57 degrees,
Right.
you just subtract that from 360.
Right. You know it's 360 all the way around a circle, right? And so if this is 57, this has got to be what's left over. So 360 minus 57 gives it 303. Yeah. Okay. And last thing, DF is called, DF is also called an intercepted arc. An intercepted arc. There's a lot of terminology here, but that's kind of it, okay? Intercepted arc. So if they say, what's the arc intercepted by angle DEF? Arc DF is its intercepted arc. Got it? Got it? And that's pretty much all I got to tell you today. Okay? Did I record everything? Hold on. I did.